आज हम लोग कुछ न्यूमेरिकल सॉल्व करेंगे रिलेटिंग टू कॉन्वेक्स लेंस एंड कॉनकेव लेंस। Now, regarding convex lens. First question, where should be the object be placed so that a real and inverted image of the same size is obtained by the convex lens? हम लोगों ने देखा we have learned the image formation by the convex lens when the object was put at different places in front of the lens. Now the question is, find the position of image. Let this be the convex lens. This is the principal axis. This is the optical center of the lens. This be principal focus F. This is 2F. Similarly, this is F dash, this is 2F dash. Now this is a convex lens, and the question is position of object when the image is of the same size. It is inverted and real, means the rays after refraction actually cut each other. So you know that this is the case when the image is at 2F. It is clearly the case that when the object is placed at 2F, the image is formed at 2F and image is of the same size and it is inverted and real. So let us draw the configuration of rays. Let us use different color. When we put an image object here, this, let it be A and B. So apply the formula for incident ray and reflected ray. Take a ray parallel to principal axis. So a incident ray parallel to principal axis after refraction goes from focus. When it emerges from the lens, it follows this path, okay? Goes from the focus. Now take another ray. If you take this ray, which passes from the optical center C, then it goes undeviated. Take this one. When it passes from the C, it goes undeviated. It will cut somewhere here. And the image is formed here. This is A dash, B dash. This is the fundamental case. There were 5 cases about the position of object before the lens. So here, when the object is at 2f, the image is formed at 2f. Since the refracted ray actually cut each other, so it is real. Image, head of the image is downward, so it is inverted. The size is same. Practically, it is found the size is same. So this is the answer. The position of image will be position of image, position of object, object, ये होगी at 2f as per requirement of image. Image should be real, inverted and same size. Okay, very simple question. Now question 2. A convex lens has a focal length of 20 centimeter. This CF is 20 centimeter. CF, focal length. Given, question says CF is equal to 20 centimeter. Where should an object be placed in front of this convex lens so as to obtain an image which is real? Okay, real means the lines after the rays after refraction will cut each other, inverted and same size as the object. This was the same question. Draw the ray diagram to show the formation of the image. This is now the answer is the position of image is 2f. Means the distance from the lens. The distance from the lens. ये यहाँ पे ये distance from the lens. ये distance, so it is 20, then it is also 20. This is 40 centimeter. If you read the questions carefully, you can solve the problem easily. Now, number 3rd. Here carefully. An object is placed at the following distances from a convex lens of focal length 10 centimeter. ये convex lens है. The same lens. Its focal length is 10. Any CF is equal to 10 centimeter. Now, an object is placed at the following distances from the lens of focal length 10 centimeter. It has seen. Number 1. When the object is placed at 8 centimeter. Now, case 1. Position of object. Number 1, 8 centimeter from the lens, from C, here from lens. Now CF is 10 centimeter. In this case, CF is 10 centimeter. Now case 1 is image Oh, sorry, object is at 8 centimeter. Now it is within the focus. C say 8. Let this be the point, and this is object A B. CB is 8 centimeter. Here given say that CB is 8 centimeter. Which position of the object will produce? सिर्फ 8 पे है, तो 8 पर है तो इमेज बना लेते हैं। कहता है कौन सी पोजीशन? डिमिनिश्ड रियल इमेज, मैग्नीफाइड रियल इमेज, मैग्नीफाइड वर्चुअल इमेज एंड इमेज ऑफ द सेम साइज एज द ऑब्जेक्ट। लेट अस ड्रॉ द फिगर, फाइंड आउट द इमेज। दिस इज incident ray after refraction passes from the focus. Yeah. Now another ray, take another ray, passes from here center. What happens? The distance between them seems to be increasing when they progress after refraction. रेफ्रैक्शन के बाद जो दोनों रे हैं आगे बढ़ रही है तो उनके बीच का डिस्टेंस बढ़ रहा है। तो इधर तो दे विल नॉट कट दिस साइड। नाउ यू गो बैक, so you will, when you will come this side, the ray is going along this line. The first ray, the first incident ray after refraction follows the path this, and passing through the focus and extended backward along this line. It seems when you see from here, it is right. When you see the ray from here, it seems that it is coming along this line. It's coming from somewhere here, not here, because the line is this. Now in the same way, when you see this ray, or you see simultaneously the both rays, what will you find? That the rays will cut at this point. When you see from here, the both rays will appear coming from this point, A dash, the image of point A, object ka head of the object is formed here at A dash. Understand clearly so that you need not further to say anything when this position is asked. So now this will be the point will be B dash. So A dash B dash will be the image of AB. So in this case, the refracted rays don't cut each other actually. So the number one, the image is not real, any virtual. इसमें the point was that which position of the object will produce? Object is at 8 centimeter. तो कौन सी position होगी image की? Description of image is given. A diminished real image? No. A magnified real image? No, not real. The image is not real because the refracted ray don't cut each other actually at any point. This seems coming from here. Virtually आभास हो रहा है, यहाँ से देखने पर ये लगता है कि यहाँ से इस पॉइंट से आ रही है। पॉइंट जो दो both rays are seems they're coming from A dash. And the next one is an image of the same size as the object? No. Next one is the magnified virtual image. Yes, this satisfies the condition. The image is magnified. It is virtual, you know it is virtual because rays don't cut actually, they seems to cut at this point. So this is virtual, you can feel it. So virtual and ये बड़ा है, large size as compared to AB, virtual and magnified. इस पॉइंट पे आप टिक करेंगे. This was the first position. Now second position is at 15 centimeter. The focal length is FB is 10 centimeter. अब लाइए हम लोग इसको आगे बढ़ते हैं, तो इसको मिटा देते हैं, इसको भी मिटा देते हैं. नया फिगर बनाना पड़ेगा नई पोजीशन के हिसाब से. पोजीशन ऑफ इमेज इन फ्रंट ऑफ लेंस, कितनी दूरी पर है, हाउ फार फ्रॉम द पॉइंट सी, हाउ फार फ्रॉम द लेंस. लेट अस रिपेयर दिस फिगर. This is the point C. Okay, given CF is 10 centimeter, this focal length is 10 centimeter. Image, so here 2F is 20. The image, it says that image is put at, object is put before the lens at 15 centimeter from the lens. So 15 in between, you get यहाँ पर, और position of object at 15 centimeter. Now, वही विकल्प, all the options, all the 4 options, diminished real, magnified real, magnified virtual, ये तो आप देख चुके, magnified virtual ये केस है नहीं, and image of the same size as the object. So let us first, how can you guess? You draw the figure and you can find out actual thing. Let it be the A and B be the object. This is the head of the object. हेड हम इसलिए बनाते हैं, जब इमेज बनेगी तो मुझे पता चले इन्वर्टेड है, ऊपर है कि नीचे है. अदरवाइज हम एक लाइन ड्रॉ कर लेते. तो दिस इज द इमेज. लेट इट स्टार्ट. The incident is parallel to this. This is go from focus. This will go from focus. Now take another ray. Let it be from, you can take 2 rays. Whether from C, that will go undeviated, or from F. After refraction, the incident ray which is coming, which is passing from the focus after refraction will be parallel to this will be the A dash B dash. F dash. This is F dash. So you see the image is, when it is, the object is between F and 2F, the image is beyond 2F. And the size will be large, inverted and real. Now the vikalp, the options. Your options are diminished real image. Diminished माने छोटी, as compared to object. Size of the image is smaller. No, not in the case, not diminished real yet. Real is, the image is real but not diminished. तो मैग्नीफाइड रियल इमेज Yes. Magnified virtual image, no. And image of the same size, no. तो this is magnified रियल इमेज, इतना ही कह रहा है, इन्वर्टेड नहीं कहा है। अगर इन्वर्टेड कहता तो ठीक था, इरेक्ट कहता तो गलत हो जाता। तो एक्चुअली इसकी प्रॉपर्टी इमेज की है, सब चीज लिख लो। जिसे मान लो और कोई पॉइंट पूछ ले, इट से इट इज इरेक्ट और इन्वर्टेड, तो दिस इज एक्चुअल यानी रियल, comma beyond 2f dash यानी other side of the mirror. Number 3, magnified या enlarged, say magnified and comma, और क्या है चौथा, रियल है, बियॉन्ड 2f है, मैग्नीफाइड है मीन्स ऑब्जेक्ट से बड़ी है, और इनवर्टेड है। इसमें से कुछ भी दिया हो, कोई कॉम्बिनेशन दिया हो, हियर ओनली 2 कॉम्बिनेशंस आर गिवन कि रियल है और मैग्नीफाइड है। तो ओके, यू टिक द रियल एंड ये थर्ड पॉइंट पे ऑप्शन है कि रियल, रियल एंड magnified. So this one is the correct. Other case is it is just 20 centimeter. So then focal length is 10 centimeter. 20 means 2f पे है, तो अभी हमने पहले जो बनाया था फर्स्ट क्वेश्चन, 2f पर है तो 2f डैश पे बनेगी, रियल होगी, सेम साइज होगी और इन्वर्टेड होगी। You have drawn the figure in question first. Now add 25 centimeter beyond 2f. It is 20 centimeter, so 5 centimeter it will come here. It will come here, so you take this figure and reverse the direction of light rays. Very interesting. You take it image, the object here, and yes, let your image is put here, this side. Then it is lens, whether you start from this side or start from this side. It is beyond 2f. It is at a distance of 25. This is 10, this is 10, 20, and this is 5, 25. This is your object. Let a ray start from here, parallel to the principal axis. After refraction, it will pass through focus. So this will pass through focus, and this will go in this way. Second ray. Take second ray, starting from here, the head of the object, this is object. Now I am taking reverse thing to solve that question. The object is put beyond 2f, any 25 centimeter. This is 10, this is 10, focal length is 10, so 2f is 20, and it is beyond 20. So now take second ray which passes from the focus, this is incident ray. This is refracted ray. This will become parallel. If focus से आ रही है तो parallel to principal axis, and this will pass here, parallel to the principal axis. So what? Here they cut the image of head of the object. And this A is at A dash, and image of B is at B dash. So this is object and this is image. So this is the next option. Here the image will be shorter as compared to the object. It is inverted, means head is this side object का, तो उल्टा हो जाएगा, image का this side, head of the image and object are opposite, so image, then the image is called inverted, not on the same direction. And the rays after refraction cut each other, actually cut each other, so this is real. इसमें है Diminished real image. Yes, diminished means shorter than object. Okay. Now, the next question. मैं धीरे धीरे पढ़ाता हूँ. I have not to show my geniusity, whether I can speak English per rata or not, or I can give a lecture to you. No, it is not so. This will not be beneficial to you, and when you understand the questions, then it is okay. Which of the following lengths would you prefer to use while reading small letters found in dictionary? Yes. तो आप देखे होंगे कभी कभी जो ज्योतिषी बैठता है हाथ में एक लेंस लेके, हैंडल लगी होती है, दैट इज कॉन्वेक्स लेंस. तो छोटी चीज़ों को बड़ा देखने के लिए. He sees the lines of the palm, so the very fine lines, the lens make them magnified, and the Jyotishi sees, the astrologer is able to see the very fine line of your palm. So which of the following lens would you prefer to use while reading small letters found in the dictionary or anywhere? Okay, it is convex lens. The answer is convex lens. A convex lens of focal length 50 centimeter. Convex lens of focal length 50 centimeter. Concave. No, not concave. A convex lens of focal length 5 centimeter. Concave lens of focal length 5. मेन है कि focal length की बात करता है. Focal length, it is confirmed. The lens is convex. One thing, let us not confuse, let us confirm. Yes, we use this lens for shaving also. So, okay, so that the image, the magnified words of the dictionary should come erect and on the same side. So it is convex lens. Okay, the case is 1 minute, very fast. This is the lens, this is f, this is 2f, and you put within the focus, and this will go from focus, and the image will be formed somewhat here. This will go from here. So this is expanding, diverging rays, so they will meet somewhere this side here. So your image will be here, A dash and B dash. So this is the case. A main thing is that he says the focal length. The lens has decided it is convex lens. The focal length given 50 centimeter or 5 सेंटीमीटर. अब देखो 50 सेंटीमीटर अगर फोकल लेंथ है तो कितनी दूर रखोगे? आधा मीटर हो गया. 100 centimeter is equal to 1 meter, so much, very big distance. So it is 50 centimeter, so that here is your dictionary and you see. So this will be the answer. कि मतलब lens should be convex with f is equal to 5 centimeter. 50 centimeter means you put your dictionary there and see from here. It will not be good. The length should be 50 centimeter workable distance. ये डिक्शनरी हाथ में लिए है या पास में रखी है, and you see the length. It comes within the focus, and it easy to read. Okay. Now the next question. Very short questions are there. Name the lens which can concentrate sun's rays to a point and burn a hole in the piece of paper. Convex lens. Sun बहुत दूर है. Sun is a very far object, and the rays, the solar radiation coming from that, they will come parallel beam of rays from the sun, and they strike the mirror or strike the convex lens, and they will meet at the focus. So concentrate at the focus. This is a rays coming, many rays coming here. This is passing from say, so this will not deviate, and all the rays will meet here at the focus after refraction. So a lot of heat energy will be produced at this pinpoint at focus, this point. So this is the convex lens. Give the usual name of the following. A point inside a lens through which the light passes undeviated. Lens के अंदर वो point. This is your lens. We see from this side. This is principal axis. This is point C. यहाँ से जो कोई रे पास होती है, that will not be deviated. Now you will see the plan of the. This is elevation. The lens is. You will see from this side, other side. The shape will be this one. A disc. What type of disc? इसके किनारे जो है. The periphery is thin. This is thin. The center is thick. This is so much. This is thick. तो यहाँ पर ये point जो है in the middle, in the center. Let this be a wheel and this will be a axle. ये the pen is a axis. So this point C. This is the optical center. So the rays passing through the optical center will not be deviated. They will remain undeviated after refraction. Okay. A 1 centimeter high object is placed at a distance 2f from a convex lens. What is the height of the image? अब 2f कहा तो आपने केस देखा है. You have seen the case. So when the object is on 2f, the image is on the 2f dash on the other side of the convex lens, and it is real and it is same size inverted. तो same size 1 centimeter का है 2f पर, तो other side में 1 centimeter की image भी बनेगी. So when the object is at 2f and length here, this is f, this is 2f. So on this side f, 2f dash f dash. तो यहाँ पर अगर 2f पे है ये, तो यहाँ पर ये उतनी ही बड़ी 1 centimeter. This is 1 centimeter. So this will also be 1 centimeter. This is the case. These are fundamental cases. So okay, image will be 1 centimeter, same size. If the image formed by a convex lens is of the same size as that of the object, What is the position of the image with respect to the lens at the same distance as that of image? ये 2f पर है तो यहाँ से डिस्टेंस ये डिस्टेंस कितनी होगी? ये फोकल लेंथ है, ये 2 टाइम्स है तो 2f, तो इधर भी इमेज का भी 2f यहाँ पे. This will be the position. The distance of image from the lens will be equal to the distance of object from the lens, but these will be on either side, opposite side. If an object is placed at the focus of a convex lens, where the image will be formed? Focus, infinity, image. This is sun's image, very far. So when the object is at focus, the image will be at infinity. Next question, where should an object be placed in front of a convex lens so as to obtain its virtual, erect and magnified? Okay, virtual, erect and magnified. This was the case. देखिए कॉन्वेक्स लेंस में जो वन साइड, लेफ्ट साइड, इफ द इमेज इज ऑन लेफ्ट साइड, this is optical, this is the principal axis, this is the optical center. In all cases, when the object is on left side and the image is formed on the right side, the image will be real inverted. It may be diminished, may be magnified, but when the image is not real, it is virtual, then this is f, this is 2f, it is f dash, this is 2f dash. In case of magnified virtual, there is only one case. This should be within the focus, between C and F. तो इसके बीच में कहीं भी, यहाँ हो सकती है, यहाँ हो सकती है, यहाँ हो सकती है, यहाँ हो सकती है. Let it be here. A, B. तो magnified and virtual इस साइड पे बनेगी, beyond 2F. ये फोकस से ले लो और इसको यहाँ से ले लो, ये दोनों जब बैकवर्ड मिलाओगे तो इट विल कम somewhere here. This will be the image. This is dotted because this is not real, so I made it dotted. In this case, this will be the image. Where should an object be placed in front of a convex lens so as to obtain its real image? कहता है किधर रखा जाए, लेफ्ट में कहाँ रखा जाए ऑब्जेक्ट की इमेज शुड बी रियल, इनवर्टेड एंड मैग्नीफाइड. रियल, इनवर्टेड, मैग्नीफाइड. फोकस पे रखेंगे तो इंफिनिटी पे बनेगी. फोकस से इधर बढ़ेंगे जो लेफ्ट साइड में, you move the object this side, the image will come this side and magnified beyond 2f, between f and 2f, when your object will be between f and 2f, then the image will be beyond 2f. This will be somewhere here, this will be inverted. रियल, मैग्नीफाइड. मैग्नीफाइड क्यों होगी? जब ये इधर मूव कर करके ऑब्जेक्ट 2f पे पहुंचेगी तब जाकर इमेज, देन द इमेज विल बी ऑफ इक्वल साइज एंड दैट विल बी ऑन हियर. तो जब तक till your object is right side of 2f, your image will be magnified beyond 2f dash. Inverted तो होगी ही, but when it move in this side, then your image will also move this side, and when the object will reach at 2f, the image will reach at 2f dash, and at 2f and 2f dash, these are the position where the object and image are of equal size. Let us take next question. For what position of an object a real diminished image is formed by a convex lens? Real image will be other side of the lens. Diminished छोटी कब होगी? देखो यहाँ पर तो बराबर ही होगी, यहाँ तक f 2f f dash 2f dash. टू एफ डैश पर when the object is at 2f dash, so image is at 2f dash, a b, a dash b dash. In this case 2f और 2f dash पे बनेगी, और here ab is equal to a dash b dash. Size same. तो कह रहा है कि इमेज इज फॉर्म रियल डिमिनिश्ड बने छोटी, तो छोटी बनाने के लिए आप ऑब्जेक्ट को इधर मूव कराइए, तो ऑब्जेक्ट शुड बी दिस साइड बियॉन्ड ऑब्जेक्ट. डिमिनिश्ड इमेज पाने के लिए ऑब्जेक्ट को आप यहाँ मूव कराइए. when it will the object will be beyond 2f on left side, the image will shift between 2f and f dash, or this will be shorter, so object will be beyond 2f. in case image है, image बनेगी real और diminished. ये this is the case. Okay. Next question. If an object is at a considerable distance, मतलब or infinity in front of convex lens, मतलब it is very far from the lens, यानी beyond 2f left side, बहुत दूर रखी हुई है, let 2f be 20 centimeter, then it is put at 10 meter. Where is the image formed? Draw the line. Where is the image formed? So when it is very far, like infinity, then image will be formed at focus. The rays will come parallel, and they will come here on the focus. See, थोड़ा सा बता दो. See, the image is this side very far. Let the rays come here from the image. These are the rays are parallel but not parallel to principal axis. If a parallel ray principal axis के होती तो F से जाती. It is not parallel, so this will after refraction, it is very far, so this will come here below F, and this will also come here below F, and that will cut here. So this will be the image of the object. Means when the object is not at infinity but it is very far from 2f on left side, the image at the focus, this is f dash point f dash f, the image will be a dash b dash at the focus. This is the focus point. Focus पर बनेगी image, but what will be the characteristic? This will be the small, any diminished, highly diminished, number one. Number two, inverted. Number three, add focus. Small, and highly, very small, highly diminished, inverted, add focus. Infinity पे है, then it will directly come to focus here. But add focus, image may be here. Very far, this would be the image A, B, and the rays are coming from this image. Okay, this is very far, so you cannot sketch properly on the board because the image is too far from the 2f, from the lens. Now, draw a given diagram in your answer book and complete it for the path of the ray of the light after passing through the lens. You have seen many figures. What type of lens? Next question. What type of lens would you use as a magnifying glass? Convex lens. How close must the object be at the lens within the focus? Name two factors on which the focal length of lens depends. Two factors. What are two factors? The curved surfaces of which the piece of glass, that is lens, is bound, and number two, the material of the lens, refractive index of the material of the lens. State if the refractive index of the material is very high, the deviation of ray after refraction will be more. So the focus f will be small, focal length will be small, focus will be near to the lens. And if the curve is, the radius of curvature is less, then the divergence will be more, then the focus will be near the lens. But these are the two factors. The curved surfaces and the material of the lens. Name two factors on which focal length. State any two uses of convex lens. There are many uses of the convex lens. We saw this for solar heating. One very major use. सोलर हीटिंग. शिरडी साई बाबा के यहाँ किचन के छत पर big mirrors are installed. Very big mirrors, very big size mirrors are installed on the roof of the kitchen. What happens? Let there is a very big mirror. Let this big. This is the mirror. Now what happens? The rays, parallel rays coming from the sun so many rays, any a greater area of the sun comes and gets concentrated at this point. Thousands, crores of rays, trillions of rays. What happens? This solar energy, the heat of the sun rays, because the number of rays in numerable rays come, and this is called the boiler. This point, you put a wooden flank at this point, it will catch fire in 20 seconds. So much heat is generated, and that heat is used to boil the water to make steam. And high temperature steam is used to make food, to cook the food there, and you can use this heat anywhere. Of water heaters, of the roof for solar water heaters, and other uses of the convex lens, chasme optic, to correct the eyesight, wear the glasses. Now some other questions. What is the lens? The first question was this is the when we started the lesson. Distinguish between a convex lens and a concave lens. Which of the two is a converging lens, convex lens or concave lens? You know, convex lens is a converging lens. You make both lenses. This is concave lens. When the rays coming parallel to this principal axis, this is C, so this is principal axis here to here. So these rays after refraction follow this. What happens? This path, this यहाँ से देखेंगे अपन, you see from here to this ray, it seems coming from the focus, because this is a parallel to the principal lens. This will also means object is placed very far at infinity. The rays are coming parallel. We have taken only two rays, so they seems diffracted from this point. When you see from this point, this ray will appear that it is coming from here, and this will also appear that it is coming from here in this direction. So this is diverging. The distance between these rays will go on increasing, and this one. When the ray will come parallel, this is here. So this will converge here. The other side, F dash. This is also focused. This has also got focus here. F dash and 2F dash. The other side of the lens, they will converge at focus. The refracted rays, the distance between rays, refracted rays goes on reducing, and they will meet somewhere. Explain with the help of diagram why the convex lens is also called a converging lens. You have seen the diagram. Define principal axis, principal focus, focal length of a convex lens. You know it. Explain with the help of diagram why the concave lens is also called a diverging lens. Now just I have made the diagram. Define the principal focus of the convex lens. You know. Draw a ray diagram to show the formation of a real magnified image by a convex lens. In your sketch, the position of the image with respect to the principal focus of the lens should be shown clearly. Draw a ray diagram to show the formation of a real magnified image by a convex lens. Magnified and real, the other side of the lens, image will be other side of the lens, and if it is magnified means larger in size as compared to object. So this should be beyond the 2f dash. Principal axis, this is f, this is 2f. This is f, this is 2f. Now, you know when the object is at 2f, the image will be at 2f dash and it will be of same size, inverted region. If the image, if you required a magnified image, then it should go beyond this. So you put this side between f and 2f. This is your sketch. A, B, draw an incident ray. It is parallel, so it will pass from the focus and take another. The f is very near. So take this ray and you will proceed and it will cut somewhere here. So this will be the A dash, B dash, beyond 2f. This is undeviated ray because it is passing from the optical center. Or you can take this ray, फोकस से जाती है तो ये let your lens be some big lens. So this will become parallel to the principal axis. Yeah. This will also cut here. The image will be A dash B dash. This is the case. You can 2 rays, 3 rays to form the image. Okay. Let us stop here because it is more or less 1 hour. Thank you for today's class. Now, on next class, we will take some questions of higher thinking, tough questions, typical questions about this, about the image formation by the convex lens. Also, we will discuss image formation by the concave lens and the formula. I will discuss the relation between V, U and F. V, the distance of image from the lens. U, the distance of image, distance of object from the lens, and F, the focal length. We will discuss in next 1 by V minus 1 by U is equal to 1 by F. This is the formula. We will take it in our next class. Okay.